Good day, dear colleagues. I would like to present a report on the topic Method, Algorithm and Computer Tool for Synphase Detection of Radio Signals in Telecommunication Networks with Noises. The authors of this research are Lilia Khvostivska, Mykola Khvostivsky, Irina Detiv and Vasil Yatsky. Known algorithms for processing radio signals for the detection of a useful component in telecommunication networks with interference are implemented using a filtering method, the core of which are mathematical models of types of random stationary process and the sum of useful signals and noise. The specified series of models are idealized through the constructive consideration of only stochastic components without combining them with a periodic component as the main feature of real radio signals with various types of modulation in telecommunication networks. Therefore, they use all predictably correlated stochastic process arsenal for the development of a new method, algorithm, and computer tool for processing radio signals for their detection in telecommunication networks with interference is actual problem. In the development process, the telecommunication network is the most vulnerable link that is affected by this disturbance of various power. Figure 1. The experimental implementation of radio signal, in particular on the example of an amplitude-modulated signal, is shown in Figure 2. All modulated radio signals in the process of their transmission are characterized by indicators of stochasticity and periodicity, which are through the influence of interference and the harmonic component in the modulation of radio signals. Radio signals in telecommunication networks with interference are represented as a periodically correlated stochastic process in the form of an expression 1. Synphase processing of the radio signal provides the process of estimating the correlation components, taking into account covariance statistics. Expression 2. Figure 3 shows the structural sequence of the research process of detecting useful radio signals in telecommunication networks with noises. The structural elements of the sequence are as follows. Synphase processing of radio signals in telecommunication network with noises according to expression 3, which calculates the detection rate in the form of correlation components. Evolution of the calculated correlation components according to the form and values of which will ensure the process of detecting radio signals. Making a decision based on the form and indicators of the estimated correlation components regarding the presence, absence of useful radio signals in telecommunication networks with noises. The algorithm for Synphase radio signal processing in telecommunication networks with noises is shown in Figure 4. The result of Synphase detection of radio signals in telecommunication networks with noises in the form of calculated correlation components with the interference power level is shown in the form of a 3D implementation in Figure 5. The level of noises dispersion is increased by 0.3 per square, and the result of the calculated components of the radio signal at this level of noises is shown in Figure 6. The level of harmful dispersion was increased to 1.2 per square, which exists the level of the most useful radio signal, and the components shown in Figure 7 were calculated. For a more detailed evolution of the calculated correlation components, their average evolution by components was used as suggested by Mykola Khvostivsky. The result of averaging the components of the radio signal at different levels of noise dispersion is shown in Figure 8. The estimated components through their averaging make it possible to compare the detection results in more detail than is the case of non-averaged components, which ensures the process of effective and reliable detection of radio signals in telecommunication networks with noises. Using MATLAB Guide, a computer tool with a graphic interface was developed to detect useful radio signals in telecommunication network with noises. Figure 9. The implemented computer tool provides a procedure for automatic the Synphase detection of a useful radio signal in telecommunication networks with noises of different power. The result of processing radio signals as a predically correlated stochastic process in telecommunication networks with noises in the form of averaged correlation components state that the developed Synphase method, algorithm, and the computer tool organize the process of the tracking and Synphase detection of the presence of a useful radio signal component against the background of noises of different power. This fact indicates the effectiveness of the process of detecting useful radio signals as a predically correlated stochastic process when using the Synphase method.